times and this gives us the mean of x and y. Okay. To find and it also gives us the standard deviation if we want that too. To find the correlation, we will go stat. So that was to find the mean. To find the R value, or the correlation, we will go stat, right arrow, which again is calculate. And we want to go to linear regression. All right. In calculus, we'll learn a lot of these other ones: quadratic, cubic, quartic, natural log, exponential, power. So those are the ones we do. We also talk about the sine graph too, but we just, in this class, we are just going to concentrate on linear only. So we hit 4. Again, should be set up. Hit enter a bunch of times. Now, the R value is not here because I need to turn on my diagnostics. Anytime the batteries get changed, for some reason the diagnostics gets turned off. So if this is the screen you got, what you have to do is go to mode and up arrow a few times till you get to diagnostics, and you want to make sure those are turned on. So the diagnostics need to be turned on. So anytime the batteries get changed, for some reason they default it to off. I don't know when you ever want it off, but make sure the diagnostics is turned on. Clear to get out of here. Redo it. Stat, calc, 4, enter a few times, and there it is. 0.969. So that concludes the second lesson. And then the final lesson of the week would be 21C. Line of best fit. Now we've probably done enough best fit lines over the last few years, but we want to make sure we know how to do it on the calculator. So we got age, and I think we got distance, whatever. You threw a ball or something. Meters. And I think we got about 12 numbers here. These are all double-digit numbers. They are not in order. Let me just count to make sure. 3, 6, 9, 10, 12. 3, 6, 9, 10. Okay, cool. So these are the ages, and this is how far each person threw the ball. That's 38. 22, 47, 18, 15, 50, 33, 27, and 20. We want to graph finding best fit line. and equation. Now we're not going to eyeball it like you might have done in algebra class. We actually need to graph this. All right, so we are going to put these numbers in a list just like we did before. So we go to Stat, Enter, and then we enter our data. Got to clear out these numbers. Oops. All right, so we're going to enter the numbers. Hit enter after each one. 12, 16, 16, 18, 13, 19, 11, 10, 20, 17, 15, and 13. 20, 35, 23, 38, 22, 47, 18, 15, 50, 33, 27, and 20. All right, so what we can do is we want to turn our stat plot on. So this might be off. If it's off, like it might be there, you just click it over to on. How I got there is I went second y equals. So let me do that again. So I can get out of here. So we go second y equals, and on the first one we want to make sure it's turned on. All right, so if yours was off, just click it to on and clear to get out of there. Check your window. The biggest number for the x is 20. Probably want to start at 0 and go a little bit beyond 20 to maybe 25. For the y, the biggest number is 50. So start at 0, and I'd maybe go a little beyond 50, whatever, 55. And there's the graph. Now to find the best fit line, or the linear regression, again we go Stat, go to Calc, which is right arrow, 4. That should be all set up. And there's our equation. .38 is the slope. -21.7 is the y-intercept. I do believe they're going to ask for the correlation. Actually, no, they won't. But if they did ask for it, it would be right here. And 0.94 would be a strong positive correlation. Remember, 0.95 is very strong, so this is not quite very strong, it would just be strong. All right, so we write down the equation. Now I can put that equation into y equals, so I hit y equals 3.38x minus 21.7. We graph that, and there we can see the line. Now, when you graph it, obviously you want to have equal intervals. So now we really don't want to break the x, but we don't really need the y-intercept. We already got the equation. So I can just graph what I see here. So I can go by whatever, 4s, 4, 8, 12, 16, 20. All right. Could have went by 5s. That might even been better. Doesn't matter. And then you can always break the y if you need to, but the x you really shouldn't. Whatever, I'll just go by 10s. 10, 20, 30, 40, 50. And then you plot your points. 12, 20, 1635, 1838, 1322, 1947, 1118, 1015, 2050, 1733, 1527, and 1320. And then we draw our line like so. Should also label age in years, distance in meters. Second question, estimate the distance if age, equals 24 using a graph. Now the key is we have to use the graph. So we technically have to extend this a little further, put in our 24, and we use the lines. So based on the graph, 55, 54, somewhere around there, and that's in meters. In my notes, let's see, I had 56, so my graph isn't really, so somewhere around there. But again, whatever it says on your graph, so somewhere around there. Next question. So done with that problem. Find the sum of the difference. Find the sum of the product of the difference of x's and y's given s sub xy, which is called the covariance. We don't really need to know that, but if it's going to be on the IB test, I figure might as well get a definition there. Well, I guess I should give you a definition. Basically, what a covariance is. Again, it's probably not that important that we know this, but it's basically how far, on average, or how much the two variables change together on average. I've never seen a question dealing with the definition of covariance, but you use the covariance formula. The formula is covariance equals the sum of the product of the difference of x and y over n. Okay, well, the covariance is 4.17. We're trying to find the sum. And the n is 6. So it's just a simple multiplication. So we multiply by 6 to both sides, and then that's our answer. 2, 0, 25. 25.02. You could round to 3 significant figures, but I don't see why you would need to. Could also give the exact answer, which I did. And then I think the last example deals with another formula called the product moment correlation. There are many correlation tests. Pearson's is the most common, but we also need to know the product moment correlation. And basically what that says is the covariance divided by the product of standard deviation of x, standard deviation of y. Those should be subscripts. Make those a little smaller. S sub x, S sub y. Again, you don't need to know that that stands for standard deviation, but it's just another formula where you just have to plug in some numbers. All right. So again, these are problems that I took right from old IB tests. If S sub x is 8.12, that's the standard deviation of x, and S sub y is 0.610, that's standard deviation of y, and the covariance is 4.52. The mean of x is 6 and the mean of y is 9. That's not needed until the second question. Find r and describe. All right, so again, the formula is the covariance goes to the top. So you can see how we just need to know how to plug in numbers into a formula. We don't even have to know this is called the covariance. We just need to know to substitute in. And at the bottom, we have the product. Now, when we punch this in the calculator, we need to make sure we put the bottom in parentheses, or the 0.610 is going to be multiplied at the top. So I'm just going to put the parentheses in just to remind me of that. You don't need to put the parentheses in the work, but it's just a reminder that when I divide, I need parentheses at the bottom, or I would get the wrong answer. All right, so we round that to 3 significant figures, 0.913. 0.913 is in the very strong, not very strong, the strong positive correlation. That's 0.87 to 0.95. Make sure you write both the strength and the direction. Some people forget the direction. Okay. Second question, and we have a formula with this one too. Determine the equation of the linear regression line. So it's similar to what we just did in the first example for y on x. Basically what that means is write it as y equals. And they even say that they want it in the slope-intercept form. Y equals mx plus b. So all that's given. All right. Now, we can't do it like the first example because there's no points to plot here. So we actually first have to put it in a formula that's very similar to the point-slope formula. Now, the point-slope formula could be written like this. Usually we put the y1 on the other side, y sub 1, but this is the point-slope formula that we should know pretty well. Well, the formula we use with correlation is very similar. The y sub 1 becomes the mean. So obviously the x sub 1 becomes the mean. And this slope is actually, could be written as the covariance over the standard deviation of x squared. It's a little sloppy. Let me write that again. S sub x squared. So these are the formulas we need to know for this chapter. And that's about it for the chapter for formulas. So the test actually would be coming up shortly next week. I don't remember which day it was going to be on, but all right, so let's finish this one off. So the mean of y is 9. Covariance is 8.12. Standard, whoops, that's the standard deviation. The covariance is 4.52. Standard deviation goes to the bottom. 8.12 squared. X minus the mean of x. The mean of x is 6. Now they want this in the slope intercept form, so we can do this all in one step here on the calculator. 4.52 divided by 8.12 squared. That's going to be my slope. So I'm going to write that number down. 3 significant figures. 0, 6, 8, 6. And now I know I have to distribute into -6 and then add 9. So I'll just do that all in one step. So times it by -6, and then I'll add the 9 to get it there. So there's the y-intercept, 8.59. And that concludes that section. If you have any questions, again, you can email me. I put the email, I think, on the first sheet. A lot of sheets here. There it is. So email right there if you need to. All right. Have a good week.